Hey everyone! So we already know about neutralization and combustion reactions. They're two common reactions in everyday life and that scientists use in their research too. What we're going to look at now though is the specific reactants and the specific products in these reactions, because they all tend to have a really similar set of products and reactants. So we're starting with combustion here actually. So we already know that combustion is when you have a fuel of some sort, something that can burn, and you mix it or you react it with oxygen. Of course you need an ignition source like a flame or a spark to get it started, but after that it just continues on its own until all the fuel is used up or all the oxygen is used up. But what every combustion reaction has in common is the products that are made. So let's look down at this picture here. So here we've got some kind of fuel burning. It looks like wood. So you've got your campfire. As that fuel's burning, we've got our oxygen molecules being sucked in from the air around. And then you can see that we've got being given off, we've got H2O, which is water, and we've got CO2, which is carbon dioxide. Got water and CO2. So these are the two reactants that always come out of a fire or a combustion reaction. The water, because the fire is so hot, the water evaporates into steam, so that's why you don't actually see water falling at the bottom of a fire when you're burning it, because all that water's evaporating into the atmosphere and you can't see it. And carbon dioxide is an invisible gas too. So this is the general word equation that every combustion reaction follows. We have our fuel and our oxygen, and they make water and carbon dioxide. Okay, so it doesn't matter what fuel it is. It could be the fuel in a wax candle here, where the fuel is the wax. Your fuel could be wood if you've got a campfire or an open fire at home. Or the fuel could be the petrol in your car engine or any other kind of engine as well that uses fuel. Okay, well there's also a general equation for neutralization reactions too. So remember, a neutralization reaction is one of the acid reactions, and it's where we have an acid and it reacts with a base. And what scientists discovered is that after the neutralization, you always have a salt left over, and then it also makes water as well. So both those chemicals are not acidic or basic at all. And that's why the pH of the product goes back to neutral. So if you need to clean up a spill of an acid and you add some base to it, then you'll make these neutral products, which makes it a lot safer if you've spilled those chemicals on the table or somewhere where you've been working. Remember, the salt is not table salt necessarily. So not necessarily table salt, which is sodium chloride. It can be any kind of salt depending on what acid and what base is used. Salt's just the general term for a particular type of chemical. Okay, so that's the general equations for neutralization reactions and combustion.